Hello class. In today's lesson, we are going to use cross multiplication, dimensional analysis, and the molarity equation to solve for molarity, moles, volume, and grams. There are a lot of different parts to this lesson, but don't worry, we're going to break it into small chunks. You will need a periodic table, a calculator, and the worksheet that goes along with this lesson. In the last video lesson, you learned about the concepts of molarity and dilution. In this lesson, we need to pull some key ideas from there, specifically the molarity equation, moles of solute divided by liters of solution, and this conversion factor, 1 liter is equal to 1,000 milliliters. Before we can get into the molarity problems, we first need to review some cross multiplication techniques. In math, you have certain problem types that require you to cross multiply in order to solve them. Typically, you have two fractions that are set equal to each other, and one of the fractions has a variable instead of a number. In this first problem, I have 1/2 is equal to x divided by 6, or x over 6. In order to solve this, we need to cross multiply. What I mean by that is we have to take the top of the first fraction and multiply by the bottom of the second fraction. So 1 times 6 is 6. And then we set that equal to the bottom of the first fraction times the top of the second fraction. 2 times x. And we end up with this equation, 6 is equal to 2x. Then we have to solve for our variable. In order to get the variable by itself, we need to divide both sides by the number that's next to the x, so that way we can get rid of that number. 2 divided by 2 is 1. And so we're left with x on one side of the equation, because 1 times x is x. On the other side of the equation, we have 6 divided by 2, which is 3. We end up with an answer of x is equal to 3. So if I go back and plug that in, I satisfy the statement that 1/2 is equal to 3 over 6. Now, most people are able to solve for that fairly easily, but when we see x in the denominator, a lot of people tend to freak out. You don't need to freak out. It uses the exact same process. So we're going to set it up just the same. 3 times x will cross multiply, and then 9 times 7. 9 times 7 is 63. We're going to divide both sides by 3. 3 over 3 is 1. And so we get x is equal to 63 divided by 3, which is 21. So then we get a statement of 9 over 21 is the same as 3 over 7. The third type of cross multiplication problem you might see is one where you have a whole number set equal to a fraction with a variable in it. Whenever you have a whole number, that whole number is the same thing as saying that whole number over 1. 28 divided by 1 is still 28, but now I've made it a fraction. And now that it's a fraction, I can cross multiply. 1 times x is x, and then in the calculator, 28 times 4 is 112. So you can still solve and cross multiply the exact same way. I just did 28 times 4 and 1 times x. Now the reason we're doing this is because we're going to need these skills to help us solve for our molarity equations. We've got 3 different forms of the molarity equation that we're going to use. The first one is the one we already know. Molarity is equal to moles over liters. And that's going to be our starting point. In this first problem, we're going to solve for moles, which means I want moles by itself. Whenever it says to solve for a variable, we're getting that variable by itself. So I see mole is on the right side of my equation. I need to get rid of liters. So I'm going to multiply by liters over 1. And I'm going to do that on both sides of my equation. What this does is causes liters on the top and bottom of the right side of the equation to cancel. And on the left side, again, anything over 1, or any number can be written as a fraction by putting it over 1. If I combine my like terms, I see liters times molarity, and then on the bottom, 1 times 1. That's just our identity factor. So liters times molarity is going to be equal to moles over 1. Again, we don't need the 1. So we end up with this equation. Liters times molarity equals my moles. This is the second form of the equation we're going to use in our problems today. The last form of the equation that we're going to use requires us to solve for liters. So molarity is equal to moles over liters, but this time I want moles by to be canceled out, and I want liters by itself. So I'm going to multiply both sides of my equation by a fraction, 1 over moles. And by doing this, I will cancel out moles. Here, the 1's cancel on the other side, and then I'm going to combine like terms. So molarity over moles is equal to 1 over liters. Again, I want liters, not 1 over liters. So what I need to do here is flip it, get the reciprocal. So by getting the reciprocal, I get this equation of liters is equal to moles over molarity. This is going to be my third equation I'm going to use to solve for my problems today. All right, first set of molarity problems. In part 1, we're going to use the same setup for all 3 questions. We're going to find molarity from the moles and volume. So we need our first equation. Molarity is equal to moles over liters. I'm given moles in my problem, and I'm given liters, so I can just plug them in. Moles over liters, 2.5 divided by 1 gives me 2.5, the capital M, for my final answer. Now go ahead and you try problems 2 and 3. Pause the video and come back when you're finished. Welcome back. I plugged in my numbers for both problems, and I got my molarities. I didn't tell you before, but it's worth mentioning now, that previously we have spent time working on significant figures. In a perfect world, I would say answer these questions in appropriate significant figures. But since it's been a long time since we've reviewed that, and we're all navigating new territory with learning at home, please use 2 decimal places for your final answer. Do not worry about significant figures. One thing I want to point out is the differences in units for question 3. You may have noticed that we were in milliliters, but our equation has liters. So there is an extra step here. 350 milliliters times 1 liter over 1,000 milliliters will help us solve and convert from milliliters to liters. By doing this, we get 0.350 liters, which is what I put in the denominator of this problem. All right, the next part, we're finding moles given molarity and volume. So this is going to use our second equation. Our second equation, moles is equal to liters times the molarity. So I just need to plug in. I have 1 liter times 2.5. Capital M is molar, but I'm going to write it a different way so that way you can see the units change. Remember, M is equal to mole over liter. So I just subbed that in that position. So where I saw a capital M, when I showed my work, I wrote mole over liter instead. I did this so that way I can confirm that my units will cancel when I multiply. They do, and I'm left with 2.5 moles. Pause the video and go ahead and try numbers 5 and 6. Welcome back. Hopefully you remembered that milliliters to liters step this time. You still needed to convert that for number 6. For number 5, you just had to multiply the two together. Again, I showed my units as moles over liter for the molarity problem. They are fairly interchangeable. Whether you see capital M or mole over liter, it means the same thing. All right, time to navigate some new territory. You will definitely need the periodic table at this point in time because it says we're finding grams. In our first video lesson, we reviewed how to find grams from moles. So we're going to break this problem down into 2 steps. We're given liters and molarity. Since we're given liters and molarity, we're first going to find moles using that second equation we talked about. And then we're going to convert to grams using our molar masses. Okay, so I have 1 liter times 3.5 moles per liter, or molar, and that's going to cancel to give me 3.5 mole of H2SO4. Now I can take that 3.5 moles of H2SO4 and convert to grams. To convert to grams, I'm going to need the molar mass. Since I started in moles, I need 1 mole on the bottom, and I need my grams of H2SO4 on top. I already calculated this, and I got a molar mass of 98.09. But if you need the periodic table, you can confirm for yourself. You should have multiplied 1.01 times 2, added that to 1 sulfur, which is 32.07, and you should also have had 16 times 4 and added that to the other 2 for a total of 98.09. Now in the calculator, 3.5 times 98.09, and remember that we multiply by the top and then divide by the bottom. So open parentheses, 98.09, divide by the bottom, and then I close parentheses. I get a value of 343.315. And like I said, we can go to 2 decimal places. 0.32 grams of H2SO4. Now, if we were talking significant figures, we would only use 2 significant figures for this problem, and our answer would look a lot different. But again, I don't want to spend the time reviewing significant figure rules at this point. They'll just make things a little more complicated for you. So we're just going to keep it simple, 2 decimal places for now. Go ahead and try the next 2 problems. Welcome back. Here we are. Multiplying the liters times the molarity to get the moles, and then times the molar mass. Don't forget, with number 9, that had the extra component of milliliters to liters first. Then you can multiply by the molarity. Half a mole times the molar mass, and we get our mass of our KCl. All right. The next problem type is very similar. It's just going in the reverse order. So first, we need to convert grams to moles, and then find our molarity. So my first step, grams of NaOH, 1 mole on top, and grams is on the bottom. So figure out your molar mass of NaOH. It is 40 grams, and we're left with 0.5 moles of NaOH here. I got that by doing 20 times 1 and then dividing by the bottom. So 20 divided by 40 is 0.5. And then I can use my molarity equation. I have moles divided by 2 liters, and I end up with 0.25 molar as my solution. 0.5 divided by 2. Go ahead and try the next two problems. Welcome back. Here we are. Again, there's two steps here. I kind of combined my work into one flow just so I could fit it into the paper. But I converted grams to moles and then did moles divided by liters for my final answer. Remember, moles divided by liters. So if you didn't convert 150 ml to liters, make sure you do that. And the way we can do that is by dividing by 1,000. You can move the decimal place over 3 to the left. A couple of different ways you can solve for that. All right, and saving the best for last. One of the last parts we have to do is find volume. That's going to use that third equation. Liters is equal to the moles divided by the molarity. So when I say third equation, I'm going back to our math background page. See, this one. Liters is the moles divided by the molarity. Okay, so here we go. I have moles, 2.74 moles divided by 1.5 molar. And then I divide those two by each other. I get a value of 1.83 liters. All right, go ahead and try the next two problems. All right, welcome back. I said next two, I really meant the next three, so hopefully you completed all three. And here we are. So I took the cross multiplication method rather than plugging it into the equation, but you could have done it either way. This is tricky because it worked in a lot of different steps. In the first one, you end up with the moles divided by the molarity, so 5.4 divided by 2 molar, and you get 2.70 liters. Not too bad. But then question 15 works in grams. So first, you have to go from grams to moles, and then you have moles and molarity, which you can use to solve for liters. So if you had your moles that you solved for divided by 0.75 molar, then you would have got an answer of 0.720 liters. And you use the exact same process for number 16. Okay. The next several sets of problems are a mix of all of the types. So before I set you free, remember, look for the context clues in the problems. If it's asking for how many of something, that means that's the variable by itself, and that's the equation we need to use. If it's asking for how many liters, use the third equation. If it's asking for how many moles, use the second equation. If it's asking for molarity, use the first equation. If it's asking for grams, or if you're starting with grams, get it to moles first, and then look for the other pieces of information that you have, and use that to find what's missing. That is all for today.